Hello, this is Kmcklintic, your instructor for Introduction to Algebra. I wanted to get started on Chapter 1's lecture. A brief overview of what this chapter is about is real numbers. Now, real numbers represents all numbers. That's the generalization of all types of numbers. Your decimals, your fractions, your negatives, positives, all numbers are real numbers. Then it's broken down into two categories. You've got your rational numbers and then your irrational numbers. Now, keep in mind, real numbers is everything, decimals everything. Now, rational numbers can be a decimal, a fraction, a whole number, negatives, positives, everything. The difference between rational and irrational is irrational can only be decimals that go on forever with no repeating. So for example, pi, which is 3.14, and it keeps going with no repeating. That's your irrational. So if it's a decimal with no repeating, you're finished. That's its only name. It's irrational. If it's a decimal that terminates, like 0.5, or repeats, like 0.6 repeating with a bar over it, either of these are rational numbers. Now, if it's a decimal, you're finished. It's rational only or irrational. Now, if it is say, the number 6, there's a subcategory to rational, and it's called integers. Integers, which I know this is really small, but it's also in your book in lesson 1.2 if you would like to see a better diagram. But integers includes all whole numbers, 1, 2, 3, 4, 5, 6, including 0, and all negative numbers, -1, -2 to negative infinity. Now the catch is there's no fractions or decimals in integers. So if you have a, say, 6, it's an integer. Now there's a subcategory to integers. If it's 6 and it's a positive, it's also considered a whole number. Now whole numbers include 0, 1, 2, 3 to infinity. No fractions, decimals, no negatives. Now how I remember whole numbers, it has an O in the middle, so I always think it starts with 0. And then of course whole numbers means no decimals or fractions. Then the subcategory of whole numbers is natural numbers. Now natural numbers I always think is how I naturally count. I naturally count starting at 1. 1, 2, 3, 4, and so on. Not including decimals or fractions. So, quick review. If it's a decimal, it's rational or irrational, that's its only name. If it's a terminating decimal or repeating decimal, it's rational only. If it's a decimal that goes on forever with no repeating, it's irrational only. Okay, now if you had, say, a non-decimal, for instance, 5. 5 would be rational, integer, whole, and natural. It has all of those names. Now if I give you the number 0, 0 is rational, integer, and whole, not natural. And then you go into the negatives. If I give you the number -5, -5 is rational, integer only. It cannot be whole or natural. Okay, so that's a generalization of how we name numbers. Now lesson 1, that's generalization of chapter 1. But lesson 1.1 reviews fractions. We know fractions, if you don't use it, you lose it. And this day and time, we're addicted to our calculators, as we all know. Even as a math teacher, I'm addicted to my calculator. Now, fractions, the key is, for adding and subtracting, you have to have a common denominator. So let's review really quick how to reduce a fraction and identify what's the numerator, what's the denominator. Now this is all in lesson 1.1, review of fractions. Now, before I forget, I recommend getting a TI-30 or above calculator. You can get these at Walmart. I think the TI-30 is like $12 or $13. And if you are going to go on to anything above college algebra, you might want a graphing calculator, which is a little more expensive. But these calculators, they will do fractions for you. Now, I'm not saying cheat on your calculator, but you can check your answers on your calculator, of course, that way to make sure you're doing it correctly. Now, if you get a TI-30 or above and you don't know how to do fractions on it, or are not sure how to reduce on your calculator, call me up. I will tell you what buttons to hit. Okay, review of fractions. If I had the fraction, say 5/10, the 5 is the numerator, spelling that wrong, numerator, and the 10 is the denominator. And how I remember denominator down. Denominator means it's down, it's at the bottom. Of course, numerator would be your top. Now, when you reduce fractions, that's only if they both have a common factor. Now, common factor means a number that will divide evenly into both numbers. So, for example, 5 is divisible by 5, and so is 10. So I can reduce by dividing by a common factor of 5. So my new fraction would be 1/2. Okay? And then say we reduce that, and then both were top and bottom were divisible by 2. Well, I divide top and bottom by 2 and keep going until there's no common factors left. Okay, now adding fractions. If you add the fraction 1/3 plus 4/6. Okay, well, they're part of different wholes. 1 is out of 3 total, the 4 is out of 6 total, so I can't just add those two. They're from 2 different wholes. So what we need to do is find a common denominator. So a common denominator would be 6. Now this would be a number that they will both divide evenly into. Now, put this up so you can see the 6's. Now, if you're not sure on the common denominator, like, I'm not even sure what it is, you could always take bottom times bottom. 3 times 6 is 18. Now, that's automatically going to be a common denominator. It will make you have to reduce more at the end, but you will get the same final answer. Okay, so if you're not sure on common denominators, just multiply the two bottom numbers. Okay, but the smallest denominator is 6. Now, you can't just change 3 to 6 on a fraction. You've got to think, okay, how did I get that 6? Well, I multiplied by 2. So if you multiply the bottom by 2 to get 6, you got to multiply the top by 2. So there's your new numerator. Now on the other side, again, 6 to 6, well, we didn't change that time, so actually it stays 6, so the top stays 4. And then you're able to add now that they're both part of the same whole. So total is 6 over 6. If it reduces, which it does, they're both divisible by 6. You have to reduce it or you will get it wrong in Math Zone. You can write it as 1 over 1. In a Math Zone, they might just let you leave it as 1. Now, something to be careful about in Math Zone is top-heavy fractions. Now, when I say top-heavy, this means, say I did my math equation, and I ended up with 12/5. Okay, now this is what we call top-heavy or improper fraction. This is the preferred answer. Math Zone does not want you to turn it to a mixed fraction. When I say mixed fraction, I would divide 5 into 12. 5 goes into 12 2 times. 2 left over, so it would be 2 and 2/5. On your calculator, most of the time it's going to do mixed fractions. If you type in a fraction problem, it's going to give you a mixed fraction answer. Well, on the TI-30s, there's an ABC button, and you can hit second ABC enter, and it will turn it top-heavy for you. You say, I don't have a calculator, and I'm not able to check it. How you turn these mixed fractions top-heavy is you take the bottom times the outside and add the top. I call it the supersede. I take 5 times 2 is 10, plus 2 more makes 12. So now I'm back where I started, 12/5. And that's what the answer will be as in your Math Zone answer key. It's going to be top-heavy fractions, or correctly called improper fractions. Okay, now, subtraction of fractions. Okay, if you had, say, 4/5 minus half. Okay, again, cannot subtract unless you have a common denominator. So, common denominator would just be what is a number that both of these will go into. Well, I can't think of a small one, so I'm like, okay, 5 times 10. Or, sorry, 5 times 2. 5 times 2 is 10. I was thinking of the answer. Okay, again, you can't just change 5 to 10. How did you get there? Well, I multiplied by 2. So I'm going to multiply the top by 2. So my new numerator is 8. Then on the other side, 2 How did I get to 10? Well, I multiplied by 5. So multiply the top by 5. So your final answer is 3/10. And again, once you get your final answer, always say, do both of these divide by the same number? Which they do not, so that is my final answer. Now let's do one with mixed fractions. If you had 1 2/3 plus 3 4/5, okay, you'd have to find a common denominator and deal with possibly adding the larger number on the outside. It can get messy. It can get confusing, especially in subtraction. So what I tell the students, always do the supersede. Turn it top heavy first. Then you can find a common denominator and not worry about adding the larger number and then the numerators. Okay, so we're going to do the supersede. 3 times 1 plus 2. So this would be 5/3. Plus, over here I'm going to supersede. 5 times 3 is 15, plus 4 makes 19. Okay, now can we add? No, we don't have the same whole. They're not the same denominators. So to get it, you can just take 3 times 5, unless you can find a smaller one, which in this case we can't. Okay, you can't just take 3 and change it to 15. How did you do that? Well, you multiplied by 5. So that means multiply the top by 5. 5 goes into 15, 3, so multiply the top by 3. Okay, now we got 25 over 15 plus 57 over 15. Now that they have a common denominator, we can add the tops. So for our tops, we'll have, 7 and 5, 12, 82 over 15. Okay, now you might say, that's a big number. I'm not sure if it reduces or not. Well, here's a little trick. If they're both even, they will always divide by 2. When they're not even, what I like to check for is if they're divisible by 3. And how you check for that is if the digits sum to a number that's divisible by 3. For example, 8 plus 2 is 10. 10 is not divisible by 3. So that one I know won't divide by 3. Now 15, 5 plus 1 is 6. 6 does divide by 3. But since the 82 does not, this is the final answer. And we want to leave it top heavy, not turn it to a mixed fraction. Okay, we got a few more key things. We need to do multiplication and division of fractions now. Okay, multiplying fractions. If I had 3/4 times, say, 2/3. Okay, the great news about multiplying and dividing is you do not have to have a common denominator. So, all I have to do is multiply top times top, bottom times bottom. So you're multiplying straight across. So it would be 6 over 12, and then reduce if possible, which they are both even, so I automatically know they're divisible by 2, so I can divide by 2 multiple times, or notice that they're both divisible by 6, and go straight to the final answer. Okay, now a shortcut. If I took that same fraction, and I saw that they both fractions have a 3 in it. Anytime you have the same number on the top and bottom, they cancel. So that could have took me to 2/4, or I could have noticed that 2 goes into 2, 1, 2 goes into 4, 2. So all that's left is a half. Now if reducing before you multiply confuses you, don't use it. Go ahead and multiply it and then reduce as you go. It's just a few extra steps. We want it to be as easy as possible for you. Don't make it complicated. Again, if you have mixed fractions, we don't like that. If I had 1 2/3 times 3 1/2, I would change them top heavy, improper. Then multiply tops times top, bottom times bottom. So just to finish this out, this would be 3 plus 2, which makes 5/3, times 2 times 3 plus 1, which is 7/2. Then I would take 7 times 5 is 35, 3 times 2 is 6. They're not both even. They do not divide by 3. So most likely that's your final answer, which in this case it is. And I'm leaving it top heavy or improper, because that's how your answer key will be. Now if you have calculator, of course, check all your answers on your calculator. Now, if it gives you the mixed fraction on the calculator, remember, if it's the TI-30, you just hit second, the ABC button, equal, and you got your answer. Now, again, any problems with the calculator, call me. I will help you out. The only calculator that sometimes is a pain is the Casio's. Don't really prefer those, but if you have it, we'll figure it out one way or the other. Okay, division of fractions. Okay, when you're dividing a fraction, say you had the fraction, or the whole number 3, and I'm dividing it by a fraction. 3 divided by 1/3. I'm saying how many 1/3 is in the 3? Well, first of all, how many 1/3 is in 1? Well, if I add up 3 1/3, I'm going to get 1. So, I'm basically saying 3 times 3. Because 1/3, there's 3 of them in 1. If I have 3 ones, there's 3 1/3 per 1. So 3, 6, 9. 9 1/3. So this equals 9. So with that in mind, they're like, okay, let's come up with a shortcut for all fractions. We can change all fraction division to multiplication. So if I had 1/2 divided by 3/4, that's the same as 1/2 times 4/3. Now the reason I can do that is when I'm dividing, just rewrite it a better way. If I had 1/2 divided by 3/4, I believe that was the original I had. If I change this to the denominator's reciprocal, notice what happens. Everything cancels. You can't just multiply the bottom by 4/3. If you do anything to the bottom of a fraction, you got to do it to the top to keep it balanced. So basically it becomes a multiplication fact. 1/2 times 4/3. So my original was 1/2 divided by 3/4. So always bring down the first fraction. Do not ever change the first fraction. Change division to times. Flip the second fraction. And then, of course, top times top, bottom times bottom. If it reduces, make sure you reduce it, which even means it reduces by 2. So this would be 2/3. And that's my final answer. Alright. I'm going to go ahead and stop this video. This is basically overview of fractions. That way in my next video I can get into order of operations, absolute value, and that sort of thing, because I don't want to put too much on each video, because I don't know if I can upload it. So anyway, I will be back with your next video here in a moment.